Hello, I'm giving a talk about Dino today. Glad to have all of you here watching. I'm located in Melbourne, Australia, and before I begin, I'd like to give an acknowledgement of country, which is something we do here in Australia. I'd like to begin by acknowledging and paying my respects for the Boon Wurrung people, the traditional custodians of the land of which I'm giving this talk today. I would like to pay my respects to their elders, past, present, and emerging, and acknowledging all Aboriginal and Torres Strait Islanders who are watching. Also paying my respects to your elders, past, present, and emerging. So first, a little bit about me. I'm originally from the US, but I moved to the UK in 2006, and then in Australia at the beginning of 2018. I used to be the project lead for Dojo, my first contribution to Dino was on the 31st of May 2018. Rise first commit was the 13th of May. So I've been working with Dino pretty much since its announcement. As a prototype. My biggest area of focus has been around TypeScript and how TypeScript integrates into the compiler within Dino to provide a sort of seamless usage of TypeScript within Dino. Dino is a new command line runtime for executing JavaScript, TypeScript, and WebAssembly. It's built with V8, TypeScript, and Rust. But why would we want to do this? So, JavaScript has changed quite a lot since Node.js was designed in 2009. We have promises, iterators, async, await, quite a lot of other syntax as well. And also the rise of ES modules. We have typed arrays. And TypeScript has become an important part of the larger JavaScript ecosystem. And Node.js has some problems. It's got a poorly designed module system with the NPM registry. It's got effectively a centralized distribution model for all of the code. Lots of legacy APIs that have to be continue to be supported. And it has a sort of trust everybody by default situation. Securing Node.js is a bit of a challenge, right? It assumes that you have unfettered access to the host environment. Especially when the 1.0 announcement came May of this year, there was a lot of sort of chatter on the internet and Twitter that Dino was out to kill Node.js, and sort of being involved in it from early on. I think myself and others, we've really never had that sort of viewpoint. We're not out to kill Node.js. Really, the viewpoint of Dino is far more like this. That development is challenging. It's a bit depressing at times, but kind of remain maybe even naively optimistic that sunshine's just around the corner. So that's kind of the world that we live in, and Node.js battles in that world just as much. The truth of it is that Node.js is a tanker ship. It is hard to move. It takes a lot of effort and a lot of collaboration with lots of people because there's so many people depending upon it. It becomes, a really hard place to be really innovative around things. Where, as the stage that Dino's at, it's far more agile, and we can move it a little bit easier. Dino may very well end up in a place similar to the way that Node.js is today. So, the real emphasis behind Dino is that it's a fun and productive system for scripting. A good scripting platform is really too useful of a tool to sort of accept the status quo. And neither Node.js, Python, nor Ruby really are acceptable fun and productive scripting system. The focus with Dino then is, we want a single executable file. We want it to always be distributed as that. And we want to try to keep it relatively compact and independent of system libraries, and have it so that the executable is all that you'll ever need to run a Dino program. Currently, it ships on Mac, Linux, and Windows. There are a couple experiments with different architectures, and who knows in the longer term where that will lead. But at the moment, it's Mac, Linux, and Windows. Like I mentioned about Node.js, that sort of trusts everybody. With Dino, we sort of a zero trust type of model. So you can run untrusted code, safely. Basically, you can go ahead and grab something off the web, run it, and know that it's not going to start doing Bitcoin mining, or being able to wipe out your hard drive. So to access the disk network, subprocesses, environmental variables, even high precision timing, the user must opt in with the command line. And so that sort of external attestation of what should be allowed to happen is a core tenet of Dino. One of the other things that is probably a little bit different from Node.js as well is that where possible, Dino uses web platform APIs. Now, increasingly, Node.js is kind of headed in that way, realizing that compatibility with the browser is probably an easier path than to continue to fight the web platform. But Dino doesn't aim to support every API. So there's some that just don't make context in it, or make sense in the context of a server type runtime. But there's quite a bit there, and it's one of those areas that we will continue to expand. Basically, whenever we try to solve a problem, we want to look at what the web platform, how they solve the problem, and if that can be easily adapted and adopted within Dino. So at the moment, we've streams, we've got the performance APIs, we've got a little bit of the crypto APIs. We have the eventing model is the same as the browser model versus doing something differently. One of the things that I think is probably the biggest mental shift for a lot of people coming to Dino is that we have these things called URLs. They've worked for us in browsers for a long period of time. I like to think of Dino as a browser for code. And so in the way that we specify modules, they are essentially fully qualified URLs. And so there's no notion of no modules or index.js. There's basically no magic resolution. Now that means that you as the implementer of a web server of modules for Dino, you can do whatever sort of magical resolution that you want to. But the Dino runtime requests a URL and expects, handles whatever comes back with that URL. And so it doesn't require any centralized server. Anybody can create a package server for Dino that's nothing more than a web server. And the runtime goes ahead and fetches, caches, and compiles the code transparently. So there isn't any work that needs to be done from the consumer perspective. And of course, because it's cached, you can go ahead and work in an offline mode with that downloaded cache. So one of the things that we wanted to do with Dino is to make TypeScript, a first-class language, and really try to get it so that it's as straightforward to run TypeScript as it is JavaScript, and from a usability standpoint, it's pretty darn close at the moment. There's still a few things that we'd like to improve in that, particularly with dealing with the correlation between JavaScript that has external types, and there are some workflows there that we need to continue to improve so that it's a little bit easier and a little bit more powerful from a transparent consistency perspective. And so because it's a first-class language, Dino describes its runtime environment with its own type definitions. It provides those to you on the command line if you want to ever reference those. And yeah, we really try to focus on cutting that down. JavaScript is also a first-class language, so everything's a ES module in Dino world, and we go ahead and inject those directly into V8 as modules. So really, the longer-term vision is that we see this natural migration from prototyping something quickly in JavaScript, sort of beginning to make it type safe in TypeScript as appropriate, and then when you sort of run into those really difficult challenges to get hot paths to perform really well in JavaScript and TypeScript, move those to Rust or WebAssembly. Rust, running under WebAssembly or whatever flavor of higher order language that you would compile down to WebAssembly to be able to give you that level of high performance there. Dino and the command line is a full set of development tools, and I think this is one of the areas that we've continued to increase the capability there. And so you can Dino info gives you all the information about the program that you're running. Dino install will install a script as a shell command. Bundle will generate a single JS file with all of your dependencies. Cache will go ahead and prefetch all of the stuff that you need and save it in the cache. And completions will generate your shell completions, and we've got a REPL, and it can upgrade itself. And the types, as I mentioned before, will print out the runtime type library, and it has a formatter built in. It has a fairly basic test harness built in as well too. Plus, you can get sort of live doc generation of code, which it's still unstable, but it's available. There is the Dino lint, which will go ahead and give you sort of a sensible defaults of linting rules for that. Some of the things that we still would like to do, particularly the Dino compile, so that you can generate a single binary distributable for a code sort of one step beyond the bundle. And then the Dino AST, abstract syntax tree. So internally, we end up parsing JavaScript and TypeScript into that abstract syntax tree, but there's a lot of potential utility within the community to be able to do more complex types of transforms and that sort of thing. So we'd like to make that available as well. So I think, as I was saying before, that one of the biggest challenges that we've had is been in the need to try to get TypeScript to be as frictionless as possible in compared to JavaScript, right? And so when we did the 1.0 announcement, it caused a bit of a ruckus and noise in there that there was a sort of call to action to move TypeScript into Rust. And I think that was probably a little bit oversimplified of what that meant. And so after that announcement, I ended up sort of drawing up a roadmap of how I saw us doing more and more in Rust. And over the last few months, we've started to chip away at that, and it's really sort of improved things quite a bit in there, and has sort of proven out that while the TypeScript compiler being written in TypeScript it makes a lot of sense for the development of TypeScript. There's some really heavy lifting that can be done much more efficiently within Rust. And so I think it's a good bit to take that heavy lifting and move that into Rust and effectively have a better user experience for everybody using Dino and using TypeScript under Dino. some of the things that we've done is the entire dependency graph is done in Rust and then supplied to the TypeScript compiler as a sort of pre-digested situation. Now, the TypeScript compiler still goes ahead and parses it and figures out those dependencies, but we're able to resolve all of those dependencies, gather any remote modules, have that all ready and warmed up before we have to invoke the TypeScript compiler. And then probably one of the biggest things, which I'll talk a little bit more on the next slide, is that we implemented a no check option. So we bypass type checking and essentially do all of the type stripping, for lack of a better term, and module transformation of the TypeScript to JavaScript in Rust without having to spin up the TypeScript compiler. So one of the things that, because we saw a real improvement there, one of the things that we thought about doing, which I think is something that we still want to heavily pursue, is to go ahead and do all that parse and transform and effectively the emit within Rust using go ahead and do that AST, feed that abstract syntax tree to the TypeScript compiler in a format that it can understand, and then effectively just do type checking within the TypeScript compiler. So, kind of the final step of moving TypeScript into Rust would be to do the type checking in Rust. Now, this is something that I just don't think is gonna be effective. So one, that actual type checking isn't as sort of heavy lifting as per se the parsing and the emitting is, which is something that can be well optimized in Rust. There's a lot of higher order of capability, a lot of memory management, and it would be really complicated to do. And given the fact that all the innovation and for good reason, the TypeScript core team is not going to stop writing the TypeScript compiler in TypeScript. So it would be effectively trying to keep up with what is really phenomenally great innovation that's going on in there, even to this day. With the stuff that in 4.1, like the recursive types that are coming, and potentially the typing of the string literals that's being worked on at the moment, which are phenomenal ways of making things more type safe. Are really would be challenging to try to reinvent that back in Rust. So I don't think we'll ever get there, and it looks like there's enough ability to increase performance without having to do that. So as I said, we have a benchmark for what we gauge the TypeScript compilation. So we have a program that's about 20 modules of TypeScript that we run through in our benchmarking to go ahead and do a full type check. And this is a situation where it's never seen these modules before, so we don't have any incremental build information, which is another way that we try to speed up the compilation. Doing that full type check, it takes about 1800 milliseconds to do that, which, when you think about 1.8 seconds, that's a fairly decent amount of time to spin things up, and would be something that we really would want to reduce. So we implemented the no check just using the transpile only capabilities of TSC, and that brought it down to about 1100 milliseconds. So a really big improvement, definitely worth the effort to be able to do that. But then we have been using in Rust a project called SWC, which is how it's the thing that powers the linting, and partly powers the formatting. There's another library on top of that, and you can see that when we implemented that type stripping just in SWC, we went down to about 75 milliseconds. So that's a huge improvement in speed there, because the the type checking bit of it is probably only a small part of the whole thing, and then there's still the emit and the transform and the parse and all of that sort of stuff. So there's an opportunity there, hopefully, when we look at the AST, that we'd be somewhere around, well, 1800, so it's 800 milliseconds, right? So still significant, better than even that with the full type checking at that point, right? So that would be an impressive feat to be able to accomplish. And we're still looking at other ways that we can speed up that process, right? There's been a lot of work to bring that down. It used to be quite a bit more, even with the full type check. All right, so time for a demo of Dino now. Personally, I like to use Visual Studio Code, and there is an official plugin for Dino in there available. This has had a bit of a bumpy ride because there were the contributors to it who sort of started it off haven't had the time to dedicate to be able to maintain it, and some things changed and we ran into some issues. So the current version is a lot more stable than the other version. We still have a lot of work to do to really bring that up to full speed and get that really ticking along well. But at least it's sort of functional again, and that can give you pretty well-rounded experience within Dino while using Visual Studio Code. So essentially what I've got here is I've got a little static web server. One of the other things that I did relatively early on in my journey with Dino is I created a middleware framework that's sort of like Express or Koa, if you're familiar with those, that provide essentially middleware web server framework. So I've got a little static website here, and I have the web server that I'm going to run here in a moment. So Dino has a fairly rich standard library, and so I'm going to be importing a few things from here to be able to give us a nice pretty console output, and going to bring in an assert in here just to do some assertion type parts of the code. And then the framework here of Oak is the web framework that will be sort of Koa-like, that will start up. So go ahead and I import those, and as you can see, those are just URLs. Because I don't have the files cached at the moment, I'm getting errors in my editor saying I don't know where that is. I can't find it. But once we download those, then these will sort of appear and type check appropriately. So we go ahead and create the application. I've created a little middleware handler here that deals with errors, a logger which will log out the response time for things, and something that adds the response time to the headers for it, and then where we're essentially serving up the static content and library. And then one of the things that, as I mentioned before, Dino tries to use the web APIs as much as possible. One of the things that I've tried to do in Oak as well is to continue to extend that model. And so we are using sort of the Dino event listener capabilities here, or the event model that's part of the web platform. And so when the server starts up, you go ahead and listen for the event just as you would in a browser. And then we have our async await. We have top level await in Dino. We've had that for quite a while, and we can go ahead and start listening to the application, which will the middleware will respond to all of the events that it receives. So if I start this, I'm going to do Dino run, and then as I mentioned before, we have to give it all of the permissions that it needs. So we need to allow it to go to the network, and we need to allow it to read that bit. Now, I could narrow what the ability I have to read down to just the static content directory, but for purposes here, it's too hard to remember what the type. So I'm going to head and just invoke our main module here. And as you can see, it's going to start to download everything from the internet. And it's now doing a full type check on the server. And once it's done that, it'll go ahead and execute the program, and we'll get a message log to the console here. A bit slower today than normal. There we go. And we're listening on there. And if we go here, I will go ahead and reload it, and you can see that we've got our little website. And if we go back, you can see that I've got my little pretty console logging going on there as well too. So really straightforward. The only real code on there we go. The only real code on here is the 1. Is 1.8K server TS. Everything else is on GitHub in this case, and there's a package registry called Deno.land/x, which is probably the biggest and most popular registry at the moment. There's a few others which make it easy to be able to identify and discover that the modules and that sort of thing. As I was saying before too, is it's a self-contained situation. So I could go ahead and format my files if I wanted to. If I wanted to find out about the server.ts and what information I have about it, I can sit here and do Dino info. And you will go ahead and get all of the dependency tree, including the file sizes and that sort of thing. 63 unique dependencies. It's 500. It's half a meg worth of code, and you can see all of that here in Dino info. This is actually going to be the next release of Dino. I'm working off of a master branch at the moment. So I think this will end up probably this week. So by the time you see this, it should be the version that's available, which includes all of that new information about the sizes of the dependencies. But you can get that full dependency tree and be able to figure out, where, if I click on this in VS Code, it will go ahead and open up. And there's this sort of online view of modules when you request the module server via browser. So let's say I wanted to find out about Oak, because I can't remember exactly what the APIs were. And so I'm going to go ahead and ask Dino to document up that module for there, and I can go through here and see all of the documentation, and I could drill down to a particular module and see that as well. But this provides all of the information of the documentation on the command line without having to go refer to anything separately or even go and browse the code if I don't want to. One of the features that I'm really passionate about, that I put a lot of work into personally, is the bundle capability, and this will give us the effectively take all those dependencies, bundle them up, and create a single sort of distributable if we wanted to, without having to get other people to be able to fetch all of the dependencies off the network and all that sort of stuff. So I'm going to go ahead and take our server DTS and go ahead and generate it as JavaScript. The other advantage of this is that it's going to do all that full type checking as well too, and what's going to be emitted is something that we know was at the bundle time, was as type safe in TypeScript as possible, which is partly why it takes a little bit longer to do that. And now we have the server.js, and if we go ahead and run that, and we have to give it the same permissions. Server.js, and you can see the startup there was significantly faster because it's only dealing with a single JavaScript module. We can go back to our web page, and we can see that we're effectively running the same code here again, same login to the console. Okay, so a little bit about the future. I think so one of the things that I'm personally working on at the moment is that is really trying to get that experience of blending JavaScript and TypeScript, and trying to get TypeScript to be as frictionless to use as JavaScript within Dino, and really trying to get that whole journey as rugged in there. One of those things is that we're going to have to revisit the whole pipeline of how we compile things through the dependency analysis and that. And then I said, we want to be able to at least start to look at what it would take to transform generate the AST in Rust and transform that and send that into the TypeScript compiler to be able to handle that and offload that whole parse, load, and transform out of TypeScript, and essentially create that as use the TypeScript compiler just as a type checker, and that should really hopefully try to get it so that there isn't a sort of tax on using TypeScript within Dino, which there is at the moment. I think one of the other things that we're doing is trying to make it a little bit easier from the internals of Dino to be able to allow people to pick and choose the parts that they need, right? The CLI is probably great for a lot of folks, but it isn't necessarily, one size fits all. Part of the whole Dino vision is to try to enable the community as a whole. Rusty V8, which is part of the Dinoland project, are the bindings in Rust to the V8 engine, with a few abstractions in there that make it a bit easier to be able to really integrate V8 into Rust really easily. There's a lot of folks that are really interested in being able to do stuff with that without having to deal with that. One of the other things that we're looking at is what we call op crates, which is essentially making the CLI a bit more pluggable as far as the sort of runtime JavaScript capabilities that are there. So the web APIs, like streams and that, we want them to be sort of separate Rust crates that you can then bring into an environment and be able to enrich a JavaScript environment without having to, sort of have this monolithic repo of JavaScript code to generate those runtime features. I think we're still on that path of journey of the being able to seamlessly sort of migrate from JavaScript and TypeScript to be able to incorporate things like Rust plugins or WebAssembly, and I think that needs a bit more work in that sort of thing, because there's that being able to evolve your code over a period of time is there, and I think we looking at that whole development experience and trying to really round that out and mature that as a whole is another thing in the future. Beyond that, I think it's we're still learning about Dino, and we're still learning about this whole bit and where needs are, and so Dino is an open collaboration, right? We've got 32 people who have 10 or plus commits to it, and that number is obviously is growing, and we really that sort of diversity of thought and opinion is something that helps keep Dino fresh and that sort of thing. On the other hand, it is really complicated. So if if you want to contribute and you're early in the process and you're not an expert at Rust, or you're not an expert at V8 and some of these other things, it may be a little bit harder to figure out things where it can be contributed. Now, on the other hand, the documentation, the editor plugins, these are some things that definitely need love and attention, and are a great way to start out on that journey of contributing. But it would be great to get more diverse group of folks contributing, and that is a little bit more representative of the sort of community that we serve. So by all means, feel free to jump on board. And that's sort of the end of the talk. Feel free to reach out to me on Twitter or other forums. Be glad to chat and have any sort of conversations, and really appreciate your time, and enjoy the rest of the conference.
Thank you for the amazing talk.
Oh,
it was awesome. It was really, really good to hear a bit about everything that Dino's going to be doing in the future. It was really, really cool. Thanks so much for joining us for it. And thank you so much for staying up so late. What time is it there?
11:15 in the evening.
Okay, we'll try and keep this fairly short then so I can let you go. So we've got a bunch of questions coming in. Anyone in the chat, feel free to drop your questions in, and we'll put them to Kitson. I'm going to be greedy and ask my question first, because I'm always curious about that. So you spoke a bit about when Dino got first announced, people were like, "Oh, Dino's going to replace Node and take over," and you suggested that wasn't really the aim. Where do you see it ending up?
We have less browsers than we did a bit ago, right? But we've had Firefox and Chrome, and that competition allows both platforms to grow and that sort of thing, right? So worst case scenario is Dino becomes a part of that ecosystem of JavaScript runtimes. That makes the whole of the ecosystem better, right? So I think we've got some slightly different focuses than that, and again we don't have sort of the 10+ years of legacy that Node.js has to sort of drag around with it, which is liberating, but of course that's a time. In a few years, it'll be the same there. But the focus is a little bit different. I mean, particularly, treating TypeScript as a first-class language is a little bit different. And so I think people will pick and choose, much as you pick and choose between, Firefox and Chrome, right? For the thing that meets your needs a bit better.
Makes sense. Yeah. I also think it's interesting. I'm curious if Node changes in reaction to Dino, because as far as I understand, lots of what Dino does differently is based off of the mistakes Ryan felt he made or were made at the beginning of Node, and an approach to fixing that, which is kind of nice. I'm curious if how Dino maybe shapes Node as well as the two go forward.
There's already been, and there continues to be, a decent amount of collaboration, right? So a lot of folks involved with Node.js have had input and shared their thoughts, and there's a decent amount of collaboration. I mean, one of the things recently that, and I know Guy Bedford's part of the panel here, he's been suggesting that we focus on some things that are on synchronizing around some things that are synergistic that only runtimes worry about, that aren't applicable to a browser, right? So that we kind of have that front, because the browser platform is never going to address it, right? And it's not something that the ECMAScript is going to address either, right? So I think there are those things where one, we can help keep each other honest, but we can also challenge each other. I think I've had a lot of collaboration with some of the folks on because we started to adopt the DOM event model into Dino, and sort of flesh that out. And Node.js has been looking at doing the same thing, right? And they're headed down that path as well. And we've shared battles and frustrations with the browser standards, right?
That's really cool. That's good to hear. So a question from the audience here. You say Dino tries to stay as close to the web/browser standards in its implementation as possible. Where does it deviate?
The most of the deviation is simply in the stuff it doesn't implement, right? So when we try to implement the browser standard, we try to hold as true to that. On the other hand, there are some really strange edge cases that where they just don't make sense for a browser. So the web standard didn't ever address it. So we kind of try to be really careful about that. For example, fetch. We're still working on trying to make it a little bit more compliant. It varies in a couple strange ways, but most of that again has to do with how you're in a server environment versus a browser environment, right?
Nice. And one from Luciano. Do you see a future where Node.js applications could be ported or integrated easily with Dino?
Yeah, so there is a part of, so one of the things that Dino has is a standard module library, and probably the most active part of the standard module library is the node compatibility stuff, right? So it continues to be fleshed out, but porting code over is possible to a degree. It's still a little bit hard to do, but I mean, is there's so much of the Node.js ecosystem that's common JS modules, and TypeScript doesn't, or Dino doesn't support those natively, right? It only supports ESM natively, and that's probably like one of the biggest challenge, even though there's ways to get around that, right? And there's a require polyfill or shim in Dino to make that porting a little bit easier.
Right, cool, nice. I think kind of hand in hand with that, the thing everyone seems to ask whenever I've mentioned Dino is immediately like, can I still use all the like npm things I normally use? And so Adam asks, are we going to see an emergent npm equivalent as a single standard repository, or are there mechanisms or architectures in place to make this ecosystem more diverse?
Yeah, so I mean, one of the fundamental things is the Dino runtime is completely unopinionated about where it retrieves its modules from, right? It's they're just URLs, right? And that was specifically built in. Dino land /x is probably the biggest collection, but there is Nest is another significant collection of that. So there's diversity there. I think the other half of it, which was the sort of, because there was another part to that question that you were kind of asking.
So it was more about there's one part was around being able to use multiple sources, and the other part was around being able to use npm modules straight, I guess.
NPM modules straight, yeah. So the biggest things is there's a couple solutions out there, and this is the benefit of not having a tied to a particular repository, right? Is both Pika CDN, which hosts up pre-bundled modules of ESM modules. You can grab, so if your NPM package has ESM modules in it, then Pika CDN can grab those. In fact, it also blends in the TypeScript types as well, and it has a header that it sends. So when you consume stuff from Pika CDN, you'll you'll automatically get the type information if it's available as well. And then the other big one that's out there is JSPM.io. Serves up a lot of modules digested in a way. So if it's ready for the browser, it's basically ready for Dino.
That's cool. It looked like in the examples I think you're using Oak, they were using the URL, like the path name for versioning. Is that like best practice going forwards with Dino, or like do you have a plan for versioning?
So Dinoland X and all the modules on there, your Git tags become the version, so to speak, in the URL, right? And you basically refer to everything by a Git tag. If you leave out the Git tag, Dinoland X will grab the last or the most recent tag and serve that up with. But yeah, so tagging. Putting the version in the URL is sort of the idiomatic way of dealing with semantic versioning in Dino. That's
really cool. And one last question before we get back to the rest of the conference. Do you know anyone using Dino in production today?
I don't spend enough time looking at it. I know there are some instances of it, and I think particularly I see a lot of chatter from there. You can run stuff both Vercel and Microsoft Azure have sort of you can run functionless stuff in both on Dino, and so I'm sure there's people out. There are, and I'm just not sure.
Fair enough. Yeah. Well, look, thank you so much. If people have other questions, where's the best place to find you? Twitter, is Twitter the place to go?
Yeah, easy. Kitson K on Twitter is probably the easiest. Yeah.
Amazing, Kitson. Thank you so much for your talk and your time.
Okay. And
I'm excited. I'm excited about the future of Dino.
Thank you very much.
Have a good evening. Take care, man.
Okay. Bye.